Hello, discrete math fans. Let's try to prove one of those set properties I just told you about. So we'll prove that for all sets A and B, A intersect B is a subset of B. What I'd like to do is first give the proof and then discuss a little bit about the structure of the proof. So the proof starts like this. Let's suppose that A and B are any sets, and let's suppose that X is any element of A intersect B. Then, X is an element of A and X is an element of B by the definition of intersection. In particular, that means that X must be an element of B. Therefore, we have now proven that A intersect B is a subset of B. All right, now that's the end of the proof. Let's talk a little bit about the proof. Now it's very important to understand that we're trying to prove a universal statement. You see, go back to the original statement, it is a for all. That's a universal statement. All right, since it's a universal statement, we have to start by saying, suppose that A and B are any sets, and they are particular but arbitrarily chosen. Not random, arbitrary. Now we have to show that A intersect B is a subset of B for these particular sets. So now we need to prove that for all X, if X is an element of A intersect B, then X is an element of B. Why do we need to prove this? Well, that's the definition of what it means to be a subset. Now this is also a universal statement. See here the for all. So to prove it, what we're going to do is we're going to suppose that X is an element of A intersect B. That is a particular but arbitrarily chosen value of X. Then we want to show that X is in B. Now filling in that gap between the suppose and the show is actually going to be pretty straightforward in this case if we use the procedural definition of intersection. So saying that X is an element of A intersect B means that X is an element of A and X is an element of B. And then we conclude directly that X is an element of B. Okay, that's all for now.